Good morning all of you. So today we will start with the moment of inertia of a section. So as we know that sometimes in case of a rotating body, the measure of inertia depends not only the mass but also on the distribution of the mass from its axis of rotation. Such a property of body is known as rotational inertia or moment of inertia, which is denoted as capital I. It is also known as the second moment, which is called as the second moment of area or second moment of mass. So in case of plane area, the formula of moment of inertia is equal to the summation of A r square, where A is the area of small element and r is the corresponding distance of the element from the line about which the moment of inertia is required to be found out. The unit of the moment of inertia, so here the unit will be expressed in meter to the power fourth or mm to the power fourth. So as per the unit given in the question, the moment of inertia unit will be different. So in case of meter, the unit will be meter to the power fourth, and in case of mm, the unit will be mm to the power fourth. So there are two kinds of method by which we can calculate the moment of inertia. So first one is by Roth's rule and the second method is by integration. The Roth's rule is used for finding the moment of inertia of a plane area or a body of uniform thickness. So now, for the rectangular portion, the moment of inertia value along the x-axis and y-axis is different. As we know that a rectangular section is symmetric about both axes, that means along the x-axis and y-axis. So that's why the value of moment of inertia also along the x-axis is different and along the y-axis is also different. So along the y axis, the value of moment of inertia in case of rectangular section is equal to BdQ by 12, where B is the width of the rectangle and D is the depth of the rectangle. Similarly, for the YY axis or the XX axis, the value of moment of inertia of the rectangular section is dBQ by 12, where the B is the width of the section and D is the depth of the section. So here is a problem. So the numerical is find out the moment of inertia of the rectangular section which having the dimension of 30 mm wide and 40 mm deep. And here we have to calculate the moment of inertia along the x-axis as well as along the y axis. So first of all, we have to write down all the data givens. So the width of the section is given as 30 mm and depth of the rectangle is given as 40 mm. So as per the formula, moment of inertia along the x-axis, the value will be b dq by 12. Hence the b value is 30 and d value is 40. So by putting the value, we have 160 into 10 to the power 3 mm to the power 4. Similarly, along the y-y axis, the moment of inertia formula will be dbq by 12, where d value is 40 and b value is 30. So by putting the value, we have the answer 90 into 10 to the power 3 mm to the power 4. So this is all about the moment of inertia of rectangular portion. Now comes to the hollow rectangular section. So here, for the hollow rectangular portion or the section, the moment of inertia along the x-axis, the formula will be b dq by 12 minus b1 d1q by 12, where this bd is the width and depth of the bigger rectangular portion and b1 d1 is the width and depth of the cut out rectangular portion, that means the smaller rectangular portion. So you can see in this figure, so this is your B, this is the D, this one is the B1 value and this much is the D1 value. So hence we know that a rectangular section is symmetric about both the axes, so the formula will be different for each axis. Hence, along the y-y axis, the value of moment of inertia is dbq by 12 minus d1b1q by 12. So now, here is another problem. So in this problem, we have to calculate the moment of inertia of the hollow rectangular section about its center of gravity if the external dimensions of the hollow rectangle is given as 60 mm width and 80 mm depth, and the internal rectangular dimension is given as 30 mm width and 40 mm depth. So first of all, we need to write down all the data givens. So for the external rectangular section, the width is 60 mm and depth is 80 mm. Similarly, for the inner rectangular portion, the width of the inner rectangle is 30 mm and inner depth is 40 mm. So as we know that the moment of inertia of the hollow rectangular portion along the x-axis is equal to b dq by 12 minus b1 d1q by 12. So by putting all the values, we have 2400 into 10 to the power 3 mm to the power 4. Similarly, along the y-y axis, the value will be dbq by 12 minus d1b1q by 12. So by putting all the values, the answer will be 1350 into 10 to the power 3 mm to the power 4. So now comes to theorem of perpendicular axis. So according to this theorem, it states that if the moment of inertia along the x-axis and the moment of inertia along the y-y axis be the moments of the plane section about two perpendicular axes meeting at O, that means according to the figure in this point, then the moment of inertia along the ZZ axis, that is IZZ, the perpendicular to the plane, and it is passing through the intersection of XX and YY axis, is given by IZZ is equal to summation of moment of inertia along the XX axis and YY axis. So by formula, the IZZ is equal to IXX plus IYY. So now coming to the moment of inertia of a circular section. So in case of circular section, we know that a circular section is symmetric about both the axes and the value of both axes are equal because the circular section is symmetric about along the XX axis as well as along the YY axis. So hence, the value of moment of inertia along XX axis and YY axis is equal for the circular section. Hence, the formula for the moment of inertia along the circular section is equal to pi d4 by 64. So here another numerical about circular section. So the problem is find the moment of inertia of a circular section of 50 mm diameter about an axis through its center. So the diameter is given as 50 mm. Hence, according to the formula, the value of moment of inertia along XX axis and YY axis are equal. So that's why the formula will be pi d4 by 64, where the diameter is given as 50 mm. So by putting this value, we will get the value of moment of inertia of the circular section as 307 into 10 to the power 3 mm to the power 4. Now coming to the moment of inertia of hollow circular section. So according to the hollow circular section, it consists of two rectangular sections. It consists of two circular sections. One is external circular section and second one is inner circular section. So you can see that the diameter of the external circular section is capital D and the diameter of the inner circular section is small d. Hence, we know that the circular section is symmetric about both the axes and the value of moment of inertia of the both axes will be equal. So that the value of moment of inertia along XX axis and YY axis is equal, which value is pi by 64 into capital D fourth minus small d fourth. So according to the numerical here, a problem is given which is a hollow circular section which have the external diameter as 80 mm and internal diameter as 60 mm. So here we have to find out the moment of inertia along the both axes. So as we know that the moment of inertia along the XX axis and YY axis are equal, so that's why we have to put the formula which is pi by 64 capital D fourth minus small d fourth. The capital D is given as 80 and small d is given as 60. Hence, the value of moment of inertia along the XX axis and YY axis for the hollow circular section is given as 1374 into 10 to the power 3 mm to the power 4.